This is California, USA, where approximately 1.7 million cows on thousands of dairy farms produce more than 13 million gallons of milk each day. But how does this enormous quantity transform into the sweet treat that once saved soldiers' lives and changed history? I visited one of the largest factories in the world to dive into the fascinating process of making condensed milk and to share the story with you. In 1856, American inventor Gail Borden developed this groundbreaking product. His invention solved the challenge of preserving milk in a time before refrigerators, making it possible to store milk in cans for up to a year. During the American Civil War, condensed milk played a crucial role in supplying soldiers with milk in combat zones where dairy cows weren't available. Thanks to its long shelf life and nutritional value, it became the go-to option for feeding soldiers. The journey of making condensed milk begins on dairy farms. To meet the high demand for this beloved product, factories like Nestlé in California operate around the clock, 24 hours a day, 7 days a week. This factory processes more than 420,000 gallons of milk daily. Massive tank trucks arrive non-stop, transporting between 130,000 and 185,000 gallons of milk each day from nearby farms. Most of the milk collected was only 6 hours old, ensuring it's incredibly fresh. However, before the milk is accepted, it undergoes lab testing. The fat and salt content must meet factory standards, and the milk must be free from antibiotics to prevent allergic reactions in consumers. But where do farmers get all this milk? Most of the milk in the US comes from roughly 60,000 dairy farms, where over 9 million cows are raised specifically for milk production. Over the past century, the milking machine has become an essential tool. The part of the machine that attaches to the cow's teat is called a cup, and it works similarly to a hand, applying pressure to the udder to extract milk. A farmer can manually milk about 6 cows per hour, but with a specialized device, that number can jump to 100 cows per hour. The ingenuity of this innovative device has optimized milk production, but the quality of the milk also depends on how well the farmer cares for their cows. The better the care, the longer the cow's life spans and the more milk they produce. On this massive dairy farm, 8,000 cows graze. It's one of many farms using technology to enhance cow living conditions and boost productivity. In milking parlors, sometimes called cow carousels, up to 80 cows can be milked at once, twice a day. Dairy cows are creatures of habit and they thrive on routine, which helps make the milking process smoother. These advanced milking parlors outperform traditional machines, increasing the milk flow rate by 30%. Before attaching the milking cups, workers disinfect the cow's udders with an iodine solution, a process that mimics the sucking motion of a calf to ensure hygienic milk production. The entire procedure takes about 7 minutes, and once milking is complete, the cups automatically detach. These cows spend about 8 hours a day eating, consuming 100 pounds of feed and drinking 80 gallons of water. A cow can produce up to 10 gallons of milk a day, 7 days a week. Thanks to technological advancements and more nutrient-rich feeds, today's cows are 3 times more productive than they were 50 years ago. A dairy cow begins producing milk at around 2 years old, once she gives birth to her first calf. Typically, the calf is separated from its mother within an hour of birth to prevent harmful bacteria from reaching the mother's udder. From then on, the calf is bottle-fed with its mother's milk, while the cow starts her milk-producing career. For 305 consecutive days, the cow is milked twice a day, after which she receives a well-deserved 60-day break to give birth to another calf. Once the new calf is born, the milking process begins again. The liquid produced by cows is a nutrient-rich substance that consists of 87% water. This process begins when food is digested in the cow's stomach and transformed into nutrients, which are absorbed into the bloodstream. These nutrients travel to the mammary glands, where they are converted into the valuable liquid we know as milk. Milk is collected from the udder at a temperature of 90 degrees Fahrenheit and transported via pumps into storage tanks, where it is cooled to a safe temperature of 36 to 37 degrees Fahrenheit. However, at this stage, the milk is still in its natural state and may contain harmful microorganisms. That's why it is loaded into a 5,300-gallon tanker truck and taken to a dairy processing plant. After passing all stages of quality control, the milk is sent to a centrifuge separator to speed up the separation process. In the top section, cone-shaped discs spin at an impressive speed of 7,000 revolutions per minute, processing over 5,800 gallons per hour. Under the force of centrifugal action, the heavier skim milk moves outward, while the lighter cream moves toward the center. As a result, we get cream with a fat content of around 20% and skim milk with a fat content of less than 1%. The skim milk serves as the base for making condensed milk. Next, the milk undergoes pasteurization to eliminate any bacteria present. To begin, the milk is first cooled to around 37 degrees Fahrenheit, then passed through a heat exchanger that raises its temperature to 162 degrees Fahrenheit. After heating, it is transferred to a chamber where it is held for 15.5 seconds to achieve the required level of pasteurization. The milk is then rapidly cooled back down to 37 degrees Fahrenheit in under 4 seconds. This complete pasteurization process reduces the bacteria count by 99%. Before the introduction of pasteurization, most milk was consumed in its natural state, leading to rapid spoilage and exposing people to the risk of infections from harmful microorganisms. In 1862, the famous French scientist Louis Pasteur proposed an innovative solution, initially aimed at preventing wine from spoiling, which was later applied to milk. After pasteurization, a large amount of sugar is added to the milk. The sugar not only sweetens the milk, but also acts as a preservative, extending its shelf life. The mixture of milk and sugar is reheated to ensure the sugar fully dissolves, creating a uniform texture. This heating also prevents the formation of crystals that could affect the smoothness of the condensed milk. Next, the milk enters an evaporator, an enormous device designed to remove water from the milk. At this stage, the milk thickens as the water content is reduced by about 60%. Using heat and pressure, the evaporator removes the water without altering the milk's essential properties, concentrating solids such as proteins, sugars, and fats. This process gives condensed milk its thick texture and sweet flavor. The evaporator consists of a series of vertical structures called calandrias. Inside each calandria are stainless steel tubes through which the milk circulates, while steam surrounds the tubes. As the milk flows downward through tiny channels, the steam heats it, causing the water to evaporate. Once the milk reaches the desired thickness, it is removed from the evaporator. Next, the milk undergoes homogenization, a process where fat is broken down into small, uniform particles to improve the milk's consistency and stability. Once this is complete, the condensed milk is ready to be packaged. The containers must first be sterilized to eliminate any microorganisms that could affect the quality of the product. Once the condensed milk has been processed and reaches the perfect consistency, it is transferred to a packaging machine. These machines precisely measure the required amount of product for each container, ensuring uniformity and minimizing waste. After the containers are filled, they are tightly sealed to prevent any contaminants from entering. To further ensure product safety, the sealed containers undergo an additional sterilization process. The cans are placed in autoclaves, where they are exposed to steam under high pressure to destroy any remaining microorganisms. This step guarantees that the condensed milk inside the container is completely safe for consumption and has an extended shelf life. In addition to meeting domestic demand, condensed milk is widely exported worldwide. Thanks to its long shelf life and high nutritional value, it is a popular product in regions with limited access to fresh milk. Countries like the United States and several European nations actively supply condensed milk to markets across Asia, Africa, and Latin America. The export of condensed milk helps strengthen international trade relationships, ensuring that people in various regions have access to quality dairy nutrition.